All right, so we are going to review the second half of 11.3, and we're going to start with this piecewise function here. And so the first thing you need to do is you need to graph it. So graphing piecewise functions aren't always easy. I suggest doing them by hand, not on your calculator. So let's go ahead and graph this one, and we'll graph it pretty accurately. So let's start with our first piece. The first piece is this right here, and this is for x is less than 2. So, but I want to actually plug in 2, even though there's going to be a circle there, it's less than 2. So I plug in 2 and I get 3. So 2, 1, 2, 3. And that's going to be an open circle, because it's not a less than or equal to, it's just strictly less than 2. And then I have to pick numbers less than 2, so I would probably choose 0 or 1, it doesn't really matter. I plug in and I get 0, I get 1, and this is just a straight line. Ooh. It's a little wavy, going that direction. All right, now I need to graph the second part, and I'm just going to switch up colors. Even though this is 1, I'm going to switch it up, and I'm going to make a little table for that one also. So this one, it goes from 2 to 4, and I want to choose 2, and I want to choose 4. I'm going to plug in 2. 2 squared is 4, minus 2 is 2. So at 2, I get this open circle at 2. And then at 4, it's a pretty big number. It's way up here at 12. So what I'm going to do is I'm just going to draw a. So, and then there's also an open circle up there, all the way up there at 12. Okay. And then finally I want to graph the last piece. So these are for numbers that are greater than or equal to 4. So let's go ahead and include 4. We plug in 4, we get the square root of 9, which is 3. So at 4, which is where this one ended, I have a point at 3, and that is a solid dot, and it goes like, like a square root. It goes like that. Okay, so that's the graph of it. And now let's go ahead and answer all these questions regarding it. So let's start here, and let's find out what this actually means. We're trying to find the limit as x goes to 1 plus. 1 plus means from the right side of 1. So let's go over to this graph, and let's look at where x is 1, and x is 1 right here. So as we're going from the right side of the graph to 1, what is the y value? Happens to be that the y value is 2. Okay. Now as we're going from the left now towards 1, which x equals 1 right there, it is also 2. Now remember, if both and left side limits are equal to each other, which they are, then the limit exists and it equals that number. And actually right here, f of 1, if I were to plug in 1 into my function, which is f of x, f of 1 would go into this piece, because that's where x is less than 2, and I get that it would be 2. And there is a dot right there. At the point 1, 2, there is a solid dot on that line. Let's look at, hold on. All right, sorry about that. Okay, so now let's look at the next one. I have the limit as x goes to 2 from the right. So 2 is a very special point over here, okay? Here's x equals 2, and x equals 2, there's a lot going on. From the right-hand side of 2, my limit is approaching 2. Okay? It's what it's approaching. So if I were standing on this graph, and I'm like, I'm walking towards 2, what is my y value getting closer and closer to? It's getting closer and closer to 2. On the other side of it, as x goes to 2 from the left. As x goes to 2, here's 2, and this is the left of 2. I'm on this graph, and I am approaching the y value of 3. All right, now the 3 and 2 are obviously not equal to each other, so the limit, as Lindsay Lohan would say, the limit does not exist. And then what is f of 2? Is there a y value at x equals 2? No, there is not. There are 2 open circles. There's no y value there. There's no y value there. So there is no y value at x equals 2. All right, let's try the next one. x goes to 3 from the right. So here we are at 3, okay, x equals 3. That's right in the middle of this parabola. And there's nothing funny happening there, okay? So as x goes to 3, we can actually plug in 3 into the parabola and get 9 minus 2 is 5. The value is actually 5. So 5 from the left is 5, at 3 is 5, and f of 3 is 5. They're all the same. All right, last one. X goes to 4 from the right. All right, so here's 4, x equals 4. From the right-hand side of 4, we are approaching a y value of 3. Okay, as we are approaching the left side, we are on the parabola. Approaching 4 from the left brings us all the way up here to 12. Now, it doesn't equal 12 there, okay, but the limit is 12. Now, these are equal to each other, so the limit does not exist. Okay, we had the limit does not exist here, and the point didn't exist either, but that's not always true, because here at f of 4, we actually have a value when x is 4, and it's on this third graph. It's a point, and that point would be at 4, 3. So the y value is 3. All right, so that's a piecewise graph. You're going to have something like that on the quiz for sure. It might be drawn out for you, or you might have to draw it yourself. All right, so here we go. Now we're going to compute each of the following limits, and all of these limits are going to either infinity or negative infinity. And so what you want to remember for these ones down here is you're really looking for the asymptote. And so remember that as x or negative infinity, it doesn't really matter. We're looking for a horizontal asymptote for these, okay? So we have 1 over x. Technically not supposed to plug it in, but if I think about 1 over infinity, that's a very, very small number, so it's going to 0. If I get something where x is bigger on the top and I'm going to infinity, well then that's also going to go to infinity or negative infinity depending. And then finally, if they're equal to each other, where I have like 2x over 3x, if the coefficient, or sorry, the degree is equal to each other, then basically they just kind of reduce out and you're left with the coefficients. All right, so let's look at a couple of these. Here we go. Obviously the denominator is a bigger, what's the word I'm looking for? Degree. The top has a degree of 0, the bottom has a degree of 5. So if I plug in infinity, I'm going to get 3 over infinity to the 5th, which is a huge number on the bottom, so this will be 0. Okay, same thing here. Going towards negative infinity, same idea. Now, this is kind of a cool one, because you don't have to find a common denominator and get that whole thing together. That would be really gross. All their separately. As x goes to infinity for a constant. Let me draw what that looks like. So for this would be plus the limit of 2 x would be 0, and the limit of 5 over 3x to the factor of just 1. Same thing here. We're going to get infinity, but that doesn't matter. This because that would give you 0. That would also give you 0. And then same thing with this one as we're going out towards negative infinity. This was y. We're still getting a value of 3 for our limit. Right. This one, you're going to do them separately. The limit as x goes to infinity for 5 times infinity. Well, 5 times infinity is just infinity. And then this. And so this would just be infinity. This, we're going towards negative infinity here. So if I were to plug in negative infinity, I would just get negative infinity. All right, so finally some good ones here. And so really, we don't even care about that negative 3 because we're way out in infinity. And so what I would do is I would do 5x over x. I would reduce that out, and the answer is 5. Same thing here, negative infinity is not really affecting this because they're going to reduce out and you end up getting 5. This one you want to look for the limit as x goes to infinity of negative 3x over 2x. And as we go towards infinity, we get negative 3/2. And they're trying to mess with you by doing a negative infinity. It doesn't matter. Those infinities are reducing out anyways. So it's still, both of them would be negative 3/2. Okay, then we get to these, and these look like big old problems, really hard. They're not. You just want to remember to look at the leading terms, okay? If they're not written in order in standard form, then rewrite them or just pull them out. And then what you get is we would get x squared over x to the 5th, that's x cubed. And as we plug in infinity, that's on the numerator, then we're going towards infinity. Ooh, but there's a negative there. So we're actually going towards negative infinity and it's cubed. So negative 3x cubed, and you plug in infinity, gives you negative infinity. This one will give you the opposite. This one gives you positive infinity. Okay. This one, we have negative 4x to the 8th over x to the 4th. If we reduce that, we get negative 4x to the 4th. If I plug in infinity here, I'm going to get negative 4. And here, if I plug in negative infinity, that's going to be to the 4th power, so that's going to make it positive, and I will get negative 4 for both of those. So on this one, it switched. This one had the negative for here and the positive for here. Oh, I said negative 4, didn't I? Negative 4 times infinity would give me negative infinity for both of these. Sorry about that, negative infinity. And I'm not going to try and trick you like that. But I hope that helped, except for, me messing up, of course, because I always mess up. But thanks for showing up. Bye.